We finish in chapter 5, the part which is related to the CNC programming. And chapter 6 is more on the CNC tooling. We already talked about the tools that we use. Can you see the slides?
Yes, sir.
Okay. So this will be more related to your course for the lab for next sem. Okay. So just you need to know some information about the tools that use with the practical or with the real CNC machines. So to have an idea about the different type of tools and why we need to use these tools, what the difference between the tool for drilling, the tool for milling, the tool for turning, and so on. So in this chapter, we are going to have some, like background or theory about these material or these tools and the materials that used to produce such tools and what are the different types of CNC tool for CNC machine. Okay, so these are the expected outcome of this chapter. And actually, this part is more on the theory part, so it's just more on the general information about the tools, materials, types, characteristic, and so on. So these are the content for this chapter. Start from the design features of CNC tool, then cutting tools for CNC machine, tooling for drilling and hole operation, cutting parameters, speed and feed. Actually, we already talked about it previously during chapter 4, because actually some of the parameters we need to write or we need to program when we write our G code. So for that, we already talked about these two parts, and also we have some examples and exercise about the speed and feed rate calculation. Then we have the type of the cutting fluids here. So starting from the design feature of the CNC tools and why we need, actually, if you remember last time when we said we need to select the type of the tool for if we want to create a hole. So for example, we select the drilling tool. If we want to just make a milling operation, so we need to change the tool to have a milling tool. So there are some of the features should be considered during the design of such operation tools. Okay, so these features, including, for example, the accuracy. So the tool should be accurate. So if I use the tool, for example, for drilling with 5 millimeter diameter or 5-inch diameter, it should be accurate to get me the exact size of hole. If I want to have a different other tool with that 10 diameter, 10 millimeter or 10-inch diameter, should give me the same. The exact hole size and so on. So the accuracy is very important for the tool. If I want to cut material with a specific angle, for example, with a specific, at specific angle, so I have to select the tools which can provide me with the accurate angle that I want to create on the workpiece. So the accuracy is one of the most important features of the CNC tooling. Then variety of operations. As you know, sometimes, it's not economical if we have, a lot or a large number of tools. So, if you want to create the hole with the if the hole with a different size, it's okay to have different tools. But sometimes you want just to create a hole at the same time you need to create to do some milling operation or to do some cutting operation. So we should have or we should consider the variety of operation that these tools can be used for. So for example, some tools they can be used for milling and at the same time they cutting. So if the tools have multiple operation or support multiple operation, so this will be a good feature on this tool. Quick changing of tools. If you are going to perform multiple operation on the same workpiece, so with using different type of tools, so you need to use, the time that will be taken to change from tool 1 to tool 2 or from tool 2 to tool 3. This time is important when you produce, for example, thousands or hundreds of parts. So the time for changing also, as the changing time is small, it will be much better than this to use such tool. Also flexibility, rigidity or withstand to the cutting force, or rigidity with this, transmit of the power at higher speed from the cutting tool or from the spindle to the workpiece. All these features should be considered during the designing of the tooling for CNC machines. So there are actually three type of materials that usually used to produce the cutting tools or the milling tool or the drilling tools for the CNC machines. So this material actually here, it depends on the nature of the the nature of the material that used to create or to produce that tools. So we have the first type is high speed steel, or the second type is cemented carbide or tungsten carbide, and the third one is the ceramic inserts. Okay, so there are some of operation prefer to use high speed steel, some other operation prefer to use cemented carbide, and others use ceramic inserts. So all these type, some depends on their applicability or the operation that need to be carried out. So this will be usually depends on the expertise of the operator of the CNC machine. So which tool should be used for that purposes. Okay, so for the high speed here, it's actually contain a combination of some of tungsten and chromium, vanadium, and different cobalt and so on. So it depends. The high when we say high speed steel, it doesn't mean that it means it consists of steel only. So it can combine with other materials, which make this tool is more harder or more with more flexibility, with more capability of perform the cutting at the high speed. So there are two main group. We call it group M and group D. So it depends on what is the base material that used to produce these tools. Actually, this more depends on, the manufacturer or the company who produce this type of tools. As a user, just to use the tool which is suitable to the specific operation. But as a manufacturer, so they have to consider what are the materials that will be produced to generate such high speed steel. In the CNC machine, you have the tools, and on these tools, for example, you are on the user manual of the CNC machine, they will explain about these tools and is it this high speed tools or is it cemented or ceramic tools and so on. Sometimes the cobalt is added to the tool to make it red hardness design. So, sir, I think there is someone waiting to be accepted into the. No, there is no one. I don't. There is no one there. Only 27 students. 27 of 37. See, of 35. That means we have 8 students absent. 2 already informed, but 6 not informed. Okay. The second type is the cemented carbide here. So it's other type, and this type of the tools is used for cutting speed, which is 3 to 4 times higher speed, comparing with the high speed steel. So this type or this type of tools is used for higher speed, comparing with the high speed steel cutting tools, and it has low toughness, but also it has high hardness and excellent red hardness. So comparing with the high speed tool. This consists from tungsten carbide and also with cobalt matrix. Here it's more on the physics or the physics materials that used to generate or to produce this type of. The third type is the ceramic tool bits, and for the ceramic tool bits here is permit for higher cutting speed, increased tool life, and better surface finish. So for this type, I mean, in order to understand what's the, I mean, what is the benefit from using that tool, or what are the difference between this type of tools as an operator for the CNC machine. So you need to refer to the user manual or the catalog that will be provided with the CNC machine, or maybe with the automatic tool changer. So we have automatic tool changer, or ATC. So this automatic tool changer, which include the box of the different tools, it will list the type of the tool that used with this CNC machine, and also it will show what will be the, for example, what is the hardness of this tool, what are the material preferred to be used with ceramic tools, what are the material preferred to use with high speed. I mean, depends on what will be the type of your workpiece. Are you going to work with ceramic? Are you, I mean, with wood, with aluminum, with copper, with I mean, with plastic or PVC and so on. So it depends on the material that you are going to use, or you are going to cut, or you are going to nail. So in this case, you are going to select the suitable tool with the suitable speed, with the suitable hardness, and so on. So the ceramic here is has a heat resistance, and also it sometimes added it will be added with the aluminum oxide or titanium oxide. So these are two of the materials that will be added to the ceramic in order to make that tool is more hardness, and it can be used at the higher cutting speed, and with a good or with a better surface finish. So these are the three type of the materials with the preferred material to be added for each type in order to improve its features and its characteristics. There are the material that we use there is used to produce different type of tools. The tools can be used for drilling, can be used for milling, can be used for turning and lathe and so on. So now we are going to talk about the type of tool for each operation. For example, we have the some specific tool just to know the how it looks like, or how the tool for drilling is looks like, how the tool for milling is looks like, and what is the difference between the tools. Actually, last time when you use the simulator, you can see, I mean, also you can, if you open your simulator and you can check the type of the available tool. There is some tools which already embedded inside the simulator. That means it's already selected with the specific diameter, specific design, and with a specific type of materials. Okay, and there is some options to add more tools. So when you add more tools, you can decide what is the dimension, what is the type, what is the material that will be used, or what is the material that will be, or this tool will be used on. For example, I'm going to use this tool with aluminum. I'm going to use this tool with wood. I'm going to use this tool with ceramic. Depends on what is the material. So you can decide what the required features for the tools in your CNC machine. But there are other tools which already embedded. So in that case, if you go for the milling tools, you go for the lathe tools, you can see, for example, 20 types of tools already there, 50 types of tools already there. This is in the case of the simulator. In the real machines, also the same. Each machine, it comes with a set of tools and for different operations, and the operator need to decide which tool he need to use for what features he want to produce. So for the tooling for drilling here, there is a one type, they call it a twist drill, and this is, I think, most of you already see with a normal drill. I mean, the drill, if you have a drill at house, so you can see how the twist drill it looks like, or even from, I mean, from the shop, if you go to buy terminals, or I mean, head for the drill, you can find different types with different size, with different shapes also. Okay, and depends on what is the, or what is the place that you want to create the hole. I mean, if I want to create a hole or drill on the wood or on the table, for example, I need to have specific type of the material. with a specific shape, with a specific specific shape, specific diameter and length and so on. So the twist drill here, usually it looks like this one. So it's come with the twist terminals here, starting from the top, from the beginning of the or the head of the drill, twist drill here, it's come with twist. So as you put this terminal on the space, on like on the wall of the house, in the normal, in the normal drill, not in the CNC. In the case of the CNC also, it has the same terminal or the same shape of the twist drill. So it is actually, this one is more it's more accurate, and also give more strength to the drill resistance definition. It can use for metal cutting, and it made from different type of material, like carbon tools or solid carbide tools. The second type of the tooling for drilling is the center drill. So the center drill, it has a specific or a different shape compared with the twist drill. So it more depends on the torque that will be generated from the center of the tool. Okay. So the initial work here is used to get the center of the drill is used like a guide to the rest of the drill part to go inside the hole. So as you can see here, this is how it looks like. We have spotting, and also we have the blend types. So it totally depends on the center. As you can see here, the center is not flat. Center part of the uh, drill here is, a little bit thinner than the original or the main body of the, for the drill. As you can see here, so the center here will start to create the drill, and it's like with smaller diameter, then the rest is come with the bigger diameter, so it goes inside. If you go to the, in the drill for the simulator, you can find such center, or with the more sharp ends, or more thinner ends, or less smaller diameter than the complete body of the drill. The same here, this is also the blade type. It has the same, it is the same, it depends on the center of the tools to create, or like the, what you can say, the, like the introduction of this device who start to create the head. It's not like in the case of the twist drill. So the twist start twisting from the first part, and it's the, with the same diameter from the beginning until the end of the material. Even there is two part here, the part which used for the create the hole, and the part which is used for, for the drill, and the part for which is used to fix the, the twist drill, or the center drill into the machine itself. So in this part, the machine, will clamp this part in order to fix it, so it's to the spindle of the machine, so it's allow for rotating this twist drill or center drill when creating the drill operation. The third type, we call it spade drill. So it consists from blade holder here, and there is different size of drill points blades. So in this case, it's not like a one piece. So it's more on the different plates on the drill itself, and it can provide more accuracy in creating the hole. And also they are designed to machine for the hole for solid passes here, and with some limitation in terms of the drill, the hole depth. So such type, it has limitation in terms of the hole depth, because as we said, it depends totally on one place, for example, which is fixed at the end of the drill itself. So as you can see here, there is one blade here, and there is a blade holder. This is the blade holder itself, and these are the blades. As you can see here, this like, like square shape with the triangular ends here, or corn head ends. So these shape or these blades will be fixed, or these blades will be fixed on the blade holder, and this plate holder will be fixed to the spindle or to the terminal of the rotating part of the machine. So it will create the horse. As you can see here, the terminal is more thicker, and sometimes they use with the different size, and sometimes this used to finishing the hole. So you already have there is already hole, but you want to make it like bigger hole or more smaller hole and so on. So they use such plate spindle, I mean speed drill tools to create such holes. Indexable insert drill here. So it's another type of the drilling tools. It's made from the carbide, and also its penetration rate for 5 to 10 times. That is for the twist and also for the speed drill. So it has more penetration rates. So it looks like this one. So as you can see here, comparing with the speed drill, the blades here are very small parts which fix at the end of the holder, and this is the part that will be changed. As you can see here, the wide range, low horsepower, double chip breaker, depends on these materials. Actually, as I told you, this more related to the workshop or to the real or to the practical CNC machines. So these terminals there that will be used for the carbide, it will be insert inside these uh, holes, and then this part will be fixed to the rotating spindle of the machine. Each type of this drill, so here for example, it requires a machine to have higher spindle horsepower. That means the rotating spindle, it should have more power and more torque, also with the coolant system and rigidity. So because it will generate a high temperature for operation, depends on the type of the inserted drill in this machine. Each type is preferred in one in specific operation, and this actually more related to the expertise of the operator of the machine, and also sometimes it depends on the required task to be accomplished. For example, you want to create some specific, you already have some hole, you want to make the holes more bigger, or you don't, you want to create some holes from scratch, you want to combine more multiple holes and so on. So it depends on the operation that you need to create. So you are going to select the suitable tools. Usually, I mean, sometimes for examples or for exercise, and in some programs, as we see before, if you remember when we have some examples about the drilling operation and so on, they explain what is the type of the tools, and also what is the size of the tools, what is the length of the tool and so on. So this will help the operator to decide. Also the type of the material that will be used to cut or that will be used to drill also has an effect on the decision on the type of the tool that will be used for the drilling operation. These are the tooling for the whole operation here. So I mean, depends, as we said, sometimes you need to create or you need to make a drill from scratch. Sometimes you already have some holes, you want to make it bigger. Sometimes you want to make it smoother and so on. This type of the tooling that used for the whole operation here, not for the, I mean, not for the drilling. From, I mean, there is one they call it the boring. So this used for enlarge the existing hole with accurate adjustment in the center location of the enlarged hole. So for example, this operation we call it the boring. Boring means enlarge of existing hole. That means you already have a hole. So you want to make enlarge and make the center of this hole accurate. That means make the center more accurate. Maybe the hole is a little bit not at the center point that decided in the I mean in the drawing or in the work in the design drawings. So you need to adjust the center, so you need to perform the boring operation. Reaming operation here to increase the accuracy of the whole dimension size. Dimension means you are going to focus more on the diameter or the radius of this hole. So you are going to make the reaming operation on this one. tabbing for cutting threads on the inside of the hole. So if there is some threads inside the hole, so you want to cut. So this operation they call it the tabbing operation. Contour boring also to enlarge of the hole to a depth slightly larger than the head of the specific bolt or pin. Sometimes this drill is not used just to create a smooth hole. I mean, not hole with a smooth side, but this hole will be created in order to be used to fix some pin or bolts inside this hole. So for counter boring here, it's used to enlarge the head of the specific bolt or pin here to allow the head to bury below the machined surface. That means it's more related to the holes that will be used to fix some bolts or some pins. So also counter shrinking here, it's used to enlarge the top end of the hole in the form of cone shape. So that means it will change the, or it will make the end of the hole in the shape of the cone, and it's not like the flat end of the shoe. So also it can be used to flash slightly below the surface when inserted. That means, to make the holes more smoother than the original one that created directly by the. So these some of the operation that need to be used in order to either enlarge or improve or add on features in the drilled holes previously by using the drilling machines. As you can see here, there are some this tooling for the whole operation that used for the whole operation. With it, you can see the different shape of these tools which used for the whole operation. That means you already have the hole. You are not required to create it. You already have the hole, but the hole is with a small size. For example, you want to increase the size. So when you put this material, or this tool inside the hole with the small diameter in the beginning and go inside, so the size of this hole will be increased based on um, the required size by the operations. So this usually such device or such material, as you can see here, this one is to create, as we said, for the for the pin or for the pulse to be inserted inside this hole. So we have the the spiral tool here, which is used to for the whole operation in order to perform the previous tooling whole operation that's required for any drilled holes by using the drilling machines. These are some of the cutting parameters that need to be considered during the performing of the whole operation or the drill operation here. So it's more related to the cutting speed and also to the spindle RPM. So these are the formula that used to find or to calculate the value of the cutting speed. And when we say the cutting speed, actually you already hear about this one when we do the exercise or the examples on the the speed, the feed and the speed rate, the speed and the feed rate previously in your assignment. So as you can see here, the cutting speed is more related to the tool circumference, which measured in the feet here. So it's not measured in millimeter, it's not measured in the inch, it is measured in the feet. So actually the tool circumference here equal to pi times tool by diameter over 12, and you can see here how this form is simplified to have this tool diameter over 4 will give you the tool cutting speed. So the tool cutting speed here in the depends on the in the the tool circumference is equal to the tool diameter over 4. So if you have the tool diameter, you divide it by 4, you can get the tool cutting speed. So this cutting speed is not the speed of the rotating of the spindle. This is the cutting speed of the machine. The cutting tools on the working speed. So if you want the spindle speed here or the spindle in RPM, it will be 4 times the cutting speed over the tool diameter. This is the formula, which more related to the spindle speed in RPM. So the spindle in RPM here are also equal to 318 times 1000 tool cutting speed over the tool diameter in the matrix unit. That means convert the feet unit here into metric units in order to find the spindle RPM. Actually, you for the spindle speed and the feed rate, you just use almost the same. I mean, depends on its millimeter or inch that we have calculated in chapter 4. You just need to follow, but in order to calculate the speed of the cutting speed, so you just divide the tool diameter over 4. Also, another cutting parameter here, I will see the cutting speed here, select for the particular tools. So, I mean, cutting speed is not fixed. It can be changed based on the tools, since it was totally depends on the tool diameter and also some of the other factors like the type of the whole operation, uh, type of the tool used, also the type of the hold down fixture of the CNC machine. So it depends on the tool that you are going to use, depends on the type of the tools, depends on the type of the whole operation that you want to perform among these different whole operations. This parameter will be changed. This for the tool feed, or in the case of the whole operation here, which is more related to the feed rate that we know before. So it's there's some formula here, like the tool feed rate, which is in inch per minute, is equal to inch per minute times inch per times r per minute here, which is revolution per minute. And also there is some another formula. There is one example to apply this formula here in this this example to show how we can apply this formula. So it said determine the feed rate for a tab having 18 threads per inch and rotate at 300 RPM. So it gives you the RPM, it gives you the thread. So you need just to find the actual feed rate. So the actual feed rate here will equal to 1 over 18, which is the revolution here, depends on this formula, IPR times RPM, which is inch per revolution times revolution per minute. So inch per revolution is equal to 1 inch per 80 revolution, because it's inch per revolution times 300 revolution per minute. So it gives you the actual feed rate. There is no, there is no differences between the way of calculating the feed rate here and the way that we have previously. That one is more focused on the, as I told you last time, it depends on what is the required information or what's the given information to perform the calculation, and also what is the type of operations. Sometimes for the cutting here, so it depends on some parameter related to the cutting or drilling. In the case of milling, it depends on parameter which more related to the milling operations.